Regarding the slab being at, what did you say it was, 81? 81%? That's not normal. I'll tell you that right now. Just a rule of thumb for the drying rate of concrete goes something like this. Approximately 30 days of drying time for each inch thickness of concrete to get to somewhere between 85 and 90% relative humidity. That's under good drying conditions, which many slabs do not see. So I want to make it very clear that yes, this slab was poured last week. Jason mentioned it had a fast drying agent, but most slabs, especially lightweight aggregate concrete slabs above grade on pan decking, are going to take a long time to dry, and often the general contractor or the engineering company on the job, they don't want to believe it because it comes down to crunch time, and you as flooring installers, your time has been crunched because all the other trades have taken up your time. And you're down to the wire, and they want you to put the flooring down. But it is what it is. It takes a long time for concrete to dry. So I just wanted to make that comment. So are there any questions? Jason and I are going to... Yes, sir.
How many of these tests do you do per 1,000 square feet?
Okay, there were two questions. The first one was, can the heat from the drilling skew your test results? And the second part of that is, how many tests per 1,000 square feet do you do? The answer to the second one is the standard for doing calcium chloride testing is 3 for the first 1,000 and 1 for every 1,000 after that. The same is true with this test method. That doesn't change, and there are some good logical reasons for that. That's why the ASTM committee developed that. The first question is, yes, there will be some heat, but we don't see, and I think my colleagues here that have some different types of competitive devices would agree with me. I don't typically see a high temperature when we first insert the device in the hole. We don't see that. But there may be an effect of wicking away some of the moisture temporarily until it comes back in the hole. That phenomenon may occur. But I haven't seen that being a big deal. But again, the acclimation time, according to the ASTM standard for documenting your readings, is 72 hours. And that will likely change to make it shorter because relative humidity is a fairly fast resulting test no matter what kind you're using, as opposed to a calcium chloride test, which requires 60 to 72 hours. But no, not much effect. I've done a lot of holes, and I don't see the temperature being hot or high. And it would probably be somewhat dependent on the concrete.
One of the things, too, that I wanted to throw out, and, of course, we're sitting there talking about, test, retest if you have to because the slab's wet. Once you do have that number that you're looking for, you have some VCTs out there, they'll go as high as 85% acceptable without doing any kind of remediation product. But whatever that number is, once you actually do find it, the other part of what we physically have is you're going to leave that sensor in the floor. And what you're going to do is there's a little metal cap that comes in that starter kit and comes with each replacement pack of sensors that will physically be dropped in the hole. And then what you're going to do is you're just going to come back with whatever kind of patching compound you're physically using and just fill the hole in. So when the guys are coming through doing their floor prep, they can just come through and they're just going to come through and just patch that whole thing in there. Now the rationale behind the metal disc is, as I continually tell people day in and day out, documentation, documentation, documentation. And one of the things we provide is a floor chart and a recording piece of paper that you can take along with the certificate calibration for the sensing device, put that in the job file. Along with that metal disc, you could actually, if push came to shove, you could go and physically show them where those tests were done at. So you have a floor that for whatever reason goes sideways. They come back, they say, did you do moisture testing? Yes, I did. You show them the documentation they have, and they say, well, that's great. You could have just written that yesterday. Oh, okay. Well, let's go on the job site. And you can physically, based on the information you have, go around and you could actually prove with a metal detector where these things are at. So it's just one additional piece of the puzzle for you to be able to cover yourself in our society that loves to litigate problems.
Hey, Jason, there are a couple more questions.
That's
I think.
fine.
One was,
what's the easiest way to, if you don't know this specific gravity?
the question is, what is the easiest way, if you don't know the specific gravity of the wood that you're trying to measure, what is the easiest, quickest way to find that out? Well, if you're on the job site, there really isn't an easy, quick way to find that out. But there are a lot of resources. If it isn't in the manual, if it isn't in a Wagner manual, I point people to resources on the internet where you can look up the specific gravity for different species and find that. But again, if you're on the job site, it's not an easy task to just know the specific gravity. Most species are known, and you know what you're going to run into when you go on the job site, usually, but not always. So the honest answer is on a job site, there's not a real easy way to do that. Yeah, good question. The question was, if it's an engineered wood with different materials in the wood, and we know what engineered wood is, are these meters effective? We don't have specific calibrations for a lot of the engineered wood products. We try to do oven dry testing and determine what some of them are. Bamboo has been a big issue in the market. We've done some oven dry testing to try and come up with settings, but there are so many it's really hard to keep up. But we do try and keep up, and I know our worthy competitors do as well to try and determine the settings for these products. So the engineered wood phenomena, it's outrunning us right now, but we're going to try and get on top of it and come up with some decent settings for engineered wood as well. But right now, that's a tougher one. Good question, though.
Two situations. How about if there's a radiant heat system under concrete? And number two, instead of concrete, I've seen where radiant heat and a layer of gypsum, which I don't think is really concrete. Can you drill in? You risk that you may hit the radiant heat that's in the slab.
Right. The question.
Stand right there.
I will. Scary. The first question was about radiant heat. If there's radiant heat in the concrete slab, what do you do about it? You don't want to hit anything, and you don't want to hit a hydronic pipe. There are a lot of things you don't want to do. There are methods to determine where the radiant heat coils are. I ran into a gentleman, actually took a call from a guy in Wisconsin, I think, maybe 2 or 3 years ago. And I've been unable to track him down again to find out. There is a type of paper that's heat sensitive, and he can lay it on the floor and it will map it, and maybe you're aware of that. I'd like to know where it is if somebody knows. And you can actually map it out and then drill. And there's something related to that, and that is, let's say you have a slab with post-tension cable in it, a structural slab. Well, you do not want to drill into a post-tension cable. That can wreak havoc on a concrete slab. So there often, before testing is done, there are companies that can come in and actually with a scanner determine where those cables are, or rebar. Usually the rebar is not part of the picture, but a post-tension cable is going to be shallow enough that you might hit it, and you do not want to hit it, so it's related to that. And then the gypcrete or gypsum type products, gypcrete's a trade name actually, but anyway, thin product over, we have a slab and then and then gypcrete over it. Well, right. There is a particular manufacturer of a gypsum product that uses RH testing, and you can use RH testing, but you just don't have to go as deep when you're doing it. So RH testing can be used on, let's call it gypcrete or gypsum overlayment kinds of products. It can be used.
And they're also on the gypsum side. They're also, any of the deep pour gypsum stuff. They're looking real hard at doing more stuff with the relative humidity testing in that application also.
Testing with subfloors, whether it's a plywood or an OSB.
The question was testing wood-based subfloors such as OSB and plywood. Yes, we have settings for those, and the other manufacturers of meters, I'm sure they have settings for OSB as well as plywood, because that's important. You need to know that for an installation of wood flooring. National Wood Flooring Association has a lot of their guidelines now, and by the way, they are moving strongly toward recommending relative humidity testing now, more strongly than they ever have for wood flooring related applications. Yes, sir. The question was, you will have expansion joints in a slab, cracks. Do you take readings near those expansion joints? The ASTM standard, ASTM F2170, is pretty much silent, not completely, but pretty much on location of where you put the sensors for testing. Common sense tells you, though, that you should test where you have a transition from one pour to another pour. That's what you're trying to do. You're trying to get a good sampling of the different trucks or different concrete loads or pours in a slab. That's part of that. And that's just common sense, because one truckload may vary a little bit in its water-cement ratio from another truckload of concrete. So testing there, I know some friends of mine, colleagues that are well known out in the industry that do that. They will test in areas that are maybe suspect or they might be otherwise concerned about. The ASTM standard does call for, and maybe one of my colleagues can correct me if I don't hit it right, I believe for slabs on grade and below grade, we want to have a sensor within 1 meter of every external wall. I think that's true. I haven't heard anybody tell me I'm wrong yet, so I guess that's right. But that's the only thing that ASTM F2170 says about location. But just use common sense where there's a different pour, where you have a transition, where you have a column perhaps and you have a lot of concrete. You have a big mass of concrete. You're going to have a different scenario there near a column. You have to remember that. Okay, our time is up. Thank you very much. We appreciate it.